Hello students, welcome back to my channel. Today we will discuss the topic of ring theory, that is a theorem on ring homomorphism and some questions related to it. Now let's get started.
नाउ एक प्रॉब्लम डिस्कस करते हैं. शो Zn is isomorphic to Z over ideal generated by N. We have the solution. Zn is equal to 0, 1. It is addition modulo ring. Addition multiplication modulo ring n minus 1. Z by n would be n 1 plus n. यहाँ पे n इसका 0 एलिमेंट है. 2 plus n and so on up to n minus 1 plus n. Define a map phi from Z over n to Zn such that phi of r plus ideal generated by n is equal to r, where r belongs to greater than or equal to 0 and less than or equal to n minus 1. Now अब हमें phi को 1 1 and well defined शो करना है. So उसके लिए हम क्या करेंगे? r plus n is equal to s plus n for some r and s belonging to this set and r not equal to s. Now it implies r minus s belongs to ideal generated by n, which in turn implies n divides r minus s, which in turn implies n is less than or equal to r minus s, which gives us a contradiction since both r and s lie between n minus 1 and 0. So उसका जो डिफरेंस है वो n से बड़ा कैसे हो सकता है, which in turn implies r is equal to s, therefore phi is well defined. अब इन्हीं स्टेप्स को अगर हम रिवर्स करेंगे तो इट कैन बी सीन दैट phi is 1 1. अब इसको होमोमॉर्फिज्म शो करने के लिए a ring homomorphism, what we did, we take two elements r and s plus n. Phi of r plus n plus s plus n is equal to phi of r plus s plus ideal generated by n is equal to phi of nq plus t plus n, where q and t are some integers and t is less than n, greater than or equal to 0, which in turn implies phi of t plus ideal generated by n, which is equal to t, which in turn is equal to r modulo s, which is equal to phi of r plus n modulo phi of s plus ideal generated by n. यहाँ पे मॉडुलो क्यों यूज किया गया, क्योंकि Zn का जो हमारे पास ऑपरेशन होता है वो इसमें और इसमें रिंग फॉर्म करता है, इसलिए तो वही प्रिजर्व्स द ऑपरेशन रिंग होमोमॉर्फिज्म. Phi of r plus n into s plus ideal generated by n is equal to phi of rs plus ideal generated by n, which in turn is equal to phi of nq dash plus k plus ideal generated by n for some q dash and k where k belongs to 0 and n minus 1, which is equal to phi of K plus ideal generated by N, which is equal to K, which in turn is equal to R multiplication modulo S, which is equal to phi of R plus ideal generated by N into phi of S plus ideal generated by N. Hence, phi is a ring homomorphism, and by definition of phi, it can be seen that phi is onto as well. For all R belonging to Zn, there exists R plus N belonging to Z by modulo ideal generated by N such that phi of R plus ideal generated by N is equal to R. Hence, we have shown that phi is in ring isomorphism, and therefore Zn is isomorphic to Z by ideal generated by N. Another problem, show that Zm can be a subring of Zn if and only if m divides n. आंसर यहाँ से प्रूव करते हैं. If Zm is a subring of Zn, then it implies Zm is a subgroup also of Zn under addition, and therefore m divides n. Conversely, if m divides n, suppose n is equal to u1 for u belonging to some integer. Define a map phi from Zm to Zn such that phi of A is equal to A. Consider phi of A modulo B, which is equal to phi of C equal to remainder obtained by dividing A plus B by M, and now phi of A plus n phi of B is equal to remainder obtained by dividing A plus B by n, which is equal to um, which in turn implies remainder obtained by dividing A plus B by n, and therefore these two quantities are equal. Similarly, phi of A multiplication modulo M B is equal to phi of A multiplication modulo n phi of B, which in turn implies phi is a ring homomorphism, which in turn implies Zm isomorphic to phi of Zm is a subring of Zn.